Normally this is
we have
unrestricted
an iris
access.
scanner system there. So I don't know if any of you have seen Angels and Demons.
Oh yeah.
It's all true.
That's where they took the eye off.
So,
Yes.
Wait, I gotta do it. Gotta make sure you get the danger feeling.
The iris scanner.
Oh my gosh.
we have to stay together.
See that little tube there? Going in? What's on from there?
Is that what's 27,000?
So the place where we can go is over here to get better.
That's where the protons go through.
The only thing that was actually vaguely correct in Angels and Demons is the surface. None of the rest. They got the eye scan wrong. That's what was scan. We don't scan those, we scan the eyes. So it's all nonsense. They didn't even get that. And they were here. And they came here. Yeah, some of it was filmed underground at the other thing.
They did film somewhere in the concern.
Tiny amounts of really, really tiny amounts. They thought CERN looked like something out of the 1950s, which most of it is, and they didn't want that.
So that's why they did it here.
Much in the US. So this is the main access shaft up there, you can just about see, where we lowered the big pieces down. In fact, we can probably just go around. Don't lean over the balconies, or if you do, don't hold your camera over the edge.
Yeah, sorry.
As far as calling them God's prophet.
One person called it that.
Well,
Not gods.
a God, right?
Yeah. Because without that, or without something like it, there'd be no solidity to the whole universe.
Defense solidity.
So
Like what I understand.
you're
is
solid.
yeah.
Absolutely. So there'd just be nothing, essentially. Particles floating around, but nothing solid, no substance to the whole universe.
So it's basically a Higgs particle is holding us together.
No, it doesn't hold us together. So gravity, for
We're
example.
talking about the Higgs particle.
Yeah, so gravity works on mass, or weight, so it attracts things together. If none of the particles had any weight, then they wouldn't attract together. You wouldn't form stars, you wouldn't form galaxies, you wouldn't form planets, you wouldn't form people. So the Higgs, the role of the Higgs is kind of a donator. It gives other particles mass. It's a very weird concept.
So let me think about it. It's something that if I have something in here and something in there, then Higgs can make it collide and create something with a mass.
No, it doesn't collide. It gives something. Don't worry about it.
No, it's just difficult
Yeah.
to
It's
understand how something can give something. Is it a matter? Is Higgs particle a matter? Like, does it, or is it like a photon that?
No, it has its own mass. It has its own energy. It has its own mass. But we don't know what it is.
And so the idea is that that energy gives energy to other particles around to make them solid.
Yes. essentially. It's like,
Give me an hour more. That'll be more.
So what's
but it's taken us dozens of years, and most of us still don't understand it. And we don't know if it's real.
It's a hypothesis that I'm testing.
Yeah.
and how long will it take to test?
Depends. Depends on nature. Because we don't know much about the Higgs, if it exists. It could have its own mass that varies between a small amount or a large amount. If it's small mass, we'll probably find it within the next 5 years. If it's a big mass, it might take us 15 years to find. So we just don't know. Depends what nature is throwing at us.
And what's the practical application if you
None.
find it? None?
Well, none that we know of, but who knows? You know, you could have said the same about discovering the electron.
Yeah.
What's the point of that?
They say it's like 50 years or something.
Well, it might take 1,000 years. It's not why we do it. We don't do it because of any direct practical application. So what we do it for is just to understand. Now on the way, when you look at some of the things in here, everything in there is cutting edge technology. Everything inside.
Very precise.
Yeah. Yeah. So at the moment we're preparing to close everything. So I was down here 2 days ago. That big orange piece was actually over there. So this is a door. Essentially it's filled with solid concrete and protects what's behind, which is you shouldn't eat anything down here. Sorry, you mustn't eat anything down here. It's a radiation zone.
You can't eat anything down here because of the radiation.
So behind there is the LHC, is the accelerator itself. But we need to protect that from radiation as well. So we have all this concrete that's there to protect it from particles.
Well, the collisions happen in
At the moment, none. But I mean, as you see behind you, it's nominally a radiation zone. So, no, not today. No.
So the collisions itself, they happen in there.
Right in the middle.
And the tube, as far as I see, basically that thing.
This is the thinnest part you see. It's about this thick.
Paul said there were 2 tubes.
Yeah, outside there are 2, but you have to bring them together. So out there are 2 tubes, and then they're brought into one, and then they collide in one single tube that goes all the way through here.
Okay.
You did. Oh no, you're not attack that.
I would say
Taxpayers.
Is it what? Taxpayers? Taxpayers?
Member states mainly, but also, so there's 20 member states of CERN, including Switzerland. And then there's what we call observer states as well, like the US. And then there's, in total, about 170 countries contribute to CERN in one way or another. With manpower, with money, with technology, whatever. So, yeah, it's expensive. I mean, the material cost of this thing in here is about 500 million Swiss francs.
What about property rights? If you find out something, who has the right to explore it economically later if you have to explore it?
In what way?
I mean, you found, let's assume, you were living some many decades ago and you would just find the electron. Yeah. So that has a huge potential economic impact for the world.
The electron is pretty easy to find though, so if you find anything in here, you need a piece of apparatus that's 3 billion Swiss francs plus 500 million to even find it again. So there's not really any possible application at the moment. There's no property rights because there's nothing.
In the future, you could use whatever you find.
Yeah, but there's no. We don't take ownership of anything.
Come on, I'm an economist. I have to think about money.
If the scientists discover something, right, and they don't know what the future application is, the point is you put it on paper, you publish it, there's this huge wow, you give lectures, and then some other guy